In this lab, we're going to be talking about my ECE120 lab project. In this project, it contains the keypad, the 7-segment display, the DC motor, and the PIC16F1937 microchip. So the keypad, the 7-segment display, and the DC motor are all connected to the PIC, and they all work hand in hand. Whatever you press on the keypad lights up on the 7-segment display, and that run for the amount of seconds on the DC motor. There's going to be a timer right here in the video showing how much time elapses with each button press. So the keypad is divided into rows and columns. N0, N1, N2, N3 are your rows, N4, N5, N6 are your columns. And how this works is that we have programmed the columns, which are N4, N5, N6, to go in between each other simultaneously in a very short amount of time, and that way it will scan itself in order to match itself with the rows. So let's say the number 7 is pressed, N4 is going to be matched with N2, so N4 scans itself very fast, and once you press that 7, the column N4 is going to be held and it matches itself with N2. So by pressing the button on the keypad, it's going to mirror itself to the 7-segment display, and let's say we press it 6, it should light up the segments A, F, E, G, D, and C, and that should look like the 6 shown in the blue image. The table being shown right now shows the output or the binary numbers that's going to be fed to the 7-segment display in order to show those key inputs. So you press a 1, you can see it, and the binary table is going to bring out a 11111001, and in hex that is 0xF9. So now I'm pressing 4 and the motor runs for 4 seconds and stops. Press 5, it runs for 5 seconds and stops. If you notice, I press the 7 button and then I press the RB0 button and then the DC motor stops. That is possible due to interrupt. By using RB0 as the interrupt button, is going to stop the DC motor from running once you press it. By the way, the RB0 button is by the lower right hand corner of the PIC board.
This is the code I have, and this is the user interrupt service routine. So we have to go to the push button, and this is the subroutine for push button. And the tables you see down here are the tables for the keypad. So in table 1 we have the keypad's actual values, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, star and pound. And in table 2, this returns the key pressed in a bit. So if 1 was pressed, you see 1, and if 2 was pressed, this is 2, so that's 1, 0. If 3 was pressed, that's going to be 1, 0, 0. And for table 3, these are the hexadecimal values that get inputted into the 7-key segment display. So that's what you see down here. So all these values are the values that are used in here. The check row subroutine is used for the checking of rows, and that way once you press a key, the row is going to stop at that exact row. And same thing goes for the checking. It just ensures that the rows are being checked. And found, that is the key debounce is just there to make sure the key doesn't bounce twice, and like if you hold it, like it's just that key that's gonna be clicked and not any other key by the side. So that's just like a delay, just to like make sure that the key is actually being pressed for that amount of time. And the key held just expatiates on the key debounce. And this is the start of the program. We set our inputs and outputs with all this code down here, and this is where the interrupts service comes in. This is our check subroutine to check for the rows and columns. Check 2 actually checks for the columns down here. and the mismatch between those two is gonna make sure we get the key that's pressed. Save key saves the key in the GPR. So this is where the move INDF function comes in. So this is an indirect form of saving the key. And pad check is the pattern check. So this is going to determine the number of seconds the DC motor runs. And the pad check, so this is where the bit check we were doing for table 3 comes in. Sorry, table 2. And because this, we have enabled it to be just 1 bit that is activated at a time. That saves us a tremendous amount of time. So for the pad check, whichever bit, that's why we use the bit test f skip if set function, because we know it's just 1 bit activated. So if there's no bit activated for that particular bit that we're looking at, then just skip to the next function or to the next command, and that's going to keep on doing until it gets to go to pattern 9. Clock turn off is used to stop the DC motor from running, and we should know that the DC motor is active low kind of motor, so it only works when it only works when 00 is sent into the DC motor. So from for pattern 1 we call delay second once, pattern 2 we call delay second 2 twice, for pattern 3 we call delay second 3 times, pattern 4 we call delay second 4 times, pattern 5 we call delay second 5 times, and that's how it goes up until pattern 6. And this is the delay second loop. It's a 1 second delay, and that is the end of it.
So thank you very much for watching, and that is the summary of how the PIC works, and the rest of the video just shows me implementing the interrupts, the keypad, the 7-segment displays, and the DC motors, and showing you how everything works.